explain everything. So let us start with sum number 38. Today we are going back. 38, then we will do 36, then 32 like this. Sum number 38, it is 0 to pi by 4. 2 tan cube x dx. All of you must know when you are doing definite integration, actually you are revising indefinite integration, nothing else. Okay? All indefinite integration sum, just limit given, change to definite. Some problems are there which you can solve with the help of definite integration concept only. That's different. But most of the sums here you can do without property also. Using by parts sometimes you have to do. For this sum, if I take 2 outside, this is going to be 0 to pi by 4 sin cube x by cos cube x dx, and everyone can write this as sin square x into sin x by cos cube x dx. So do one thing before you make any substitution, that it will be two outside 0 to pi by 4 sin square x you write 1 minus cos square x into sin x by cos cube x dx. Put cos x equal to z. So I is equal to 2 into, when x 0, z is 1, when x pi by 2, z is 0. So there will be 1 minus z square, sin x dx is minus dz, this divided by z cube, done. So you take 2 outside and this minus is getting absorbed by z cube dz, 1 to 0. This is 2, 1 to 0 dz by z, z to the power minus 3 dz. All of you understand? So there will be 2 into, so if you have taken cos x equal to z, and when you are changing the limit, all of you can see that limit changing will be done in accordance with this. When x equal to 0, z is 1 and it was pi by 4, not pi by 2. When x equal to pi by 4, this will give you z is equal to cos pi by 4, that is 1 by root 2. So here it will be 1 to 1 by root 2. Alright? Because it is 0 to pi by 4. So this is also 1 to 1 by root 2. And this one also the same manner, 1 to 1 by root 2. So there if you do, it will be log z (1 to 1 by root 2). This is z to the power minus 3 plus 1 by minus 3 plus 1. 1 by 2 z square. So this is changed to 2 into this plus j you put minus half. This you write log 1 minus half log 2 half minus half log 2. So answer is going to be 1 minus log 2. Okay. Now let us do sum number 36. This is based on the last property, which we haven't done any sum based on the last property so far, that minus a to a fx dx will be equal to 0 if a from minus x equal to minus fx. Alright. If a from minus x equal to minus fx, then the result is 0. It means if the given function is an odd function, the result will be equal to 0. For 36, the result will be 0 because this is going to be an odd function. But you need to show your calculation how it is an odd function of x. Okay, whatever marks given for it, you will show how this is an odd function and then proceed. So your first step will be to prove that this function is an odd function. 36 minus 1 to 1 x to the power 17 x to the power 17 cos to the power 4x. You let x to the power 17 cos to the power 4x as fx. You assume this. So f of minus x going to be what? It is minus x to the power 17 cos to the power minus 4x. I am wrong because minus x to the power 17, this is odd power, you know. There will be minus sign before. So minus sign before, it will give us minus fx. So your conclusion will be, therefore, the given function or integrand, whatever you say, x to the power 17 cos to the power 4x is an odd function. So the result is minus 1 to 1 x to the power 17 cos to the power 4x dx is going to be equal to 0. Please check once. I am going little bit out of the textbook sums, where again I am setting one sum which you have to find the answer in definite integration. Like suppose it is given minus pi by 2 to pi by 2 sine to the power 19x dx. Okay, if you are asked to evaluate this, maybe 1 or 2 mark given. There also you'll remember such a huge power we cannot calculate. We cannot calculate in a day. So what you will do there, you will think whether the last property of definite integration helping us or not. That is minus a to a fx dx is 0 if it is an odd function. So here fx is sine to the power 19x. Again, f of minus x is, so this is nothing but minus sine to the power 19x So this is nothing but minus fx. Therefore, the result is, this is odd function. Again, the result going to be equal to 0. Is that clear? And next, we are going to do this sum, because 33, this kind of sum, and 31 we have done before. We are going to do two very important sums, 32 and 30, both, even 27 also. Let us do 32 first. X tan x by sec x plus tan x. And it is from 0 to pi. 0 to pi x tan x by sec x plus tan x. This you cannot put odd or even function. You cannot go by that property. Okay? But we have to use property. If you say that no, I'll do it by parts, then you are not doing right. Because by parts, x you can take first function, remaining as second function, it's huge. Okay? You can do another method. Multiply numerator by sec x minus tan x. Then sec square x minus tan square x will give you 1. And calculation will be easier. But still there is x tan square x. You have to use by parts over there. But before by parts, let's see whether property helps us or not. And the most important property is the third one. 0 to a fx dx is nothing but 0 to a f of a minus x dx. I'm going to use this property. Okay. So this will be I equal to 0 to pi minus x tan pi minus x sec of pi minus x tan of pi minus x dx. Pi minus x tan x divided by, isn't it? Now if you are going to add these two, see the main part where you have problem with x when multiplied by x, this is going to be eliminated. So add these two, right? I plus I is equal to 0 to pi x plus pi minus x tan x, that divided by sec x plus tan x dx. So their pi will remain outside. 0 to pi tan x by sec x plus tan x dx. Okay. So 2i equal to pi into, express in sines and cosines. Sin x by cos x, 1 by cos plus sin by cos. So there will be sin x by 1 plus sin x. Okay. See how seventh property arises here. Because if you make any substitution, or if you say that I can do it without property you can do, but you can do this also. We are in a position to apply this, that 0 to 2a fx dx is equal to 2 into 0 to a fx dx if f of 2a minus x equal to fx. But I think you can do it by without using that even. I is equal to pi by 2, you multiply numerator by 1 minus sin x. Sin x into 1 minus sin x will be there by cos square x dx. So this will be 0 to pi. Sin x by cos square x will be tan x into sec x minus sin square by cos square, 0 to pi. Alright. So it will be pi by 2 only. This is sec x, 0 to pi. This is sec square x minus 1. Okay. Now simplify it. Sec pi minus sec 0 pi by 2. So sec pi by 2 is what? Minus 1. Minus 1. Pi by 2 into minus 2 will be there. So there will be pi square by 2 minus pi. Okay. Go for the next problem. Sin x plus cos x by 9 plus 16 sin 2x. We'll do it here. Enough space is there, I think. So first I keep this one open for you. Those who haven't done it, check once. This is the sum. Okay, x tan x by sec x plus tan x. I did it there by using the property 0 to a fx dx once, and then I did not use the second property. 0 to 2a fx dx I did not use. I did it without property only. Now go for this sum, number 30. Can do it here. You can start it here. Thirtieth sum is 0 to pi by 4 sin x plus cos x by 9 plus 16 sin 2x dx. Okay. This you write, this you did not use property as I see it here. Property I think not required for this. Okay. Let us see. You write denominator, because we see 9 sin x plus cos x is there. When sin 2x is there, this we have past experience can be written as 1 minus sin x minus cos x whole square. Am I right? This you always can write in this form. Because sin square x plus cos square x is 1. Minus 2 sin x cos x minus sign is there. So it will be sin 2. So one can write sin 2x in this form so that I will be changed to 0 to pi by 4 this divided by oh no, 9 is there and then remaining part also there. 16 into this thing will be there. So denominator going to be 9 plus 16 . So this is 0 to pi by 4, that divide by 25 minus 16, so put sin x minus cos x equal to z. When x equal to 0, z is minus 1. Okay. So if we substitute there and the limit is changed when x equal to 0, z is going to be 0 minus 1. That is minus 1. And when pi by 4, the result going to be 0. So dz by, because derivative of this is cos x plus sin x dx will be equal to dz 25 minus 16z square. If you take 1 by 16 outside, dz by 25 by 16, which you can write as 5 by 4 whole square minus z square. All of you understand the manipulation. Take 16 as common. Then this is done. Okay. So 1 by 16, 1 by 2a log of a plus x by a minus x. So there is 4 by 160. I mean 1 by 40 log of, take z equal to 0 over there. If we take z equal to 0, it's coming log 5 by 4 by 5 over 1 minus log of minus 1 if you put. So it is 1 by 4 plus 9 by 4. So this thing is changed to log 1 is 0 minus log 1 by 9. Log 1 minus log line, so it will be plus. Log 9 you can write as log 9 you can write as log 3 square. 2 will come outside. 2 by 40 log 3. But in some book they have kept the answer this manner only.